In this video, we're going to introduce you to the concept of radians. We'll talk about what a radian is, and we'll compare degrees and radians. We've talked a lot about angles in right triangles, and now we've talked about angles in standard position. But we've only used one unit of measure, degrees. There's another unit of measure we can use, and that's called radians. In fact, as you progress with calculus, you'll be using radians more and more, and degrees less and less. To talk about radians, I'm going to use a software package called Trig Explorer. You're not required to purchase this, but in case you're interested, Trig Explorer is a software package that's sold at www.mathrealm.com, and I'll be using it to demonstrate radians. Before we talk about radians, we need to go back to a circle. The circumference of a circle, the distance around a circle, is given by the following formula. The circumference, c, is equal to pi times d, where d is the diameter of the circle. Well, we've talked about what a radius of the circle is. The radius is the distance from the center point of the circle to the outside edge of the circle. And a diameter is simply a line that goes through the circle, going through the center of the circle. In fact, looking at this, you can see that the diameter is simply 2 times the radius. So we could rewrite this circumference formula. Instead of c equals pi d, we could also say c is equal to 2 times pi times r, where again d is either the diameter of the circle, or in the second case r is the radius of the circle. Let's go back to the formula c equals pi times d. Now you've probably heard this formula before, but let's solve for this symbol pi. Pi is equal to the circumference divided by the diameter. What does that mean? Using the software Trig Explorer, we see that pi is equal to, or approximately equal to, 3.1416. Pi is an irrational number. It's a number without end in its decimal places, and it never repeats. And it just so happens that this number appears if we take the circumference of any circle and divide it by its diameter. It doesn't matter if we talk about a large circle. For instance, this circle has a circumference of 1,209, or this circle with a circumference of 405. Both of these circles, if you take that circumference and divide it by the diameter, you get 3.1416, and then a whole bunch of other numbers. And you can also see that pi doesn't have any units. You can see that inches, in this case, reduces out of both the numerator and the denominator. So pi is a constant without a unit. What does this mean? Well, if we took a circle with diameter equal to 1, the circumference would be pi times d, or pi. So if we took that diameter of 1 and saw how many fit into its circumference, we would get 3.1416. If you were interested in the first 1,800 decimal places of pi, well, here they are. We won't be requiring you to know that for this class, however. Well, now let's go back to talking about our unit circle. Remember, our unit circle had radius equal to 1. Well, if the radius is 1, that makes the diameter 2 times 1, or 2. And if we find what the circumference of a unit circle is, we find that, again, the circumference is pi times d, or pi times 2, or, as is more often written, c is equal to 2 pi. So that means the distance around a circle, if we start here at our red point and go around this circumference, getting back to our main point, we will have gone a distance equal to 2 pi. So if we, instead of talking about degrees on our unit circle, if we talk about pi, we know at that starting point we're equal to 0 degrees, or, if we remember our coterminal angles, one complete rotation was equal to 360 degrees. Well, if instead of 360 degrees, we think of that rotation as 2 pi, then we're able to start thinking of angles in terms of radians and not just degrees. If a complete rotation is 2 pi, that means half a rotation, that is halfway around the circle, what we used to call 180 degrees, would now be pi. Well, let's look at our 90 degrees next. If 90 degrees is halfway between 0 and pi, then I suspect in radians we would be talking about an angle of pi over 2. And our last point, 270 degrees, well, that's a pi plus half that distance again. So I believe that would be pi plus pi over 2, or adding together our fractions, 3 pi over 2. Okay, well that didn't seem too hard. But now here's a typical homework question. Find the point on the unit circle determined by 7 pi over 4. Well, what on earth am I going to do with that? I see pi, pi over 2, 3 pi over 2, I see nothing over 4. So obviously I can't do this. Well, of course we can. We just have to pull out a little bit of work with fractions. And what I like to do is, looking at this, is I pull out full pi's. For instance, 7 pi divided by 4 is equal to 4 pi over 4 plus 3 pi over 4. And I know that 4 pi over 4 is just going to equal pi, because the 4 in the numerator and the 4 in the denominator will divide out. So then I'm left with pi plus 3/4 pi. Well, I know pi gets me to what I used to call 180 degrees, and if from pi to 2 pi would be another pi, 3/4 of the way from pi to 2 pi will probably give me a point about there. And this will take a little bit of practice and a little bit of fraction work, but I think after a couple of homework problems you'll be more comfortable with this. Then, just as you're comfortable with pi and fractions, you'll get a question such as this. Find the point on the unit circle determined by 2.8. Well, where did my pi go? Well, whatever you do, please do not change this to 2.8 pi. If there's no pi there, that means don't put one in. Because remember, pi is not a unit. Pi is a number. It's an irrational number, but it's a number nonetheless. If I wanted to approximate pi, then I would say, well, that point, that angle, is about equal to 3.14. So if I wrote pi, or if I wrote approximately 3.14, we're talking about the same thing. Remember, pi is not units. Pi is just a number. Well, if that's 3.14, and I want to find a point of 2.8, well, it's got to be before the 3.14. Let's see, what would pi divided by 2 equal? If I plug that into my calculator, I find that's approximately equal to 1.57. So I'm guessing that this point is probably pretty close to 2.8. Again, if it said 2.8 degrees, we'd talk about a whole different number. But if the question asks for 2.8, if there's no units listed, that means we're talking about radians. Well, say I did want to look at what 1 radian is. Well, where would 1 radian fall? I'm guessing 1 radian would be about there. What if I also asked you to find the point on the unit circle determined not by 1 radian, but 1 degree? Well, 1 degree would be something like that. In fact, that might even be too big. So I want you to understand that if I ask you to show me the point determined by 1, or the point determined by 1 degree, they're two very, very different numbers. There's 360 degrees in a circle, but there's only 6.28 radians in a circle. Notice up above I did say 1 and then parentheses rad. Sometimes you'll see that abbreviation, but most likely it would just say 1.